Hey everyone, my name is Elizabeth Marmo, and today I will be presenting my Lab 2 findings for Physics 2211. For this lab, the purpose was to drop an object from rest that would have fallen slower than a rock to study the effects of drag. With this, we used Newton's second law and the momentum principle to support our findings, as these principles address the changes in velocity and thus acceleration. To summarize this lab, I used a paper plate as my object because wider, flat objects are more affected to drag due to their nature. I then recorded this motion at an initial height of 0.66 meters with other initial conditions. With this recording, I then uploaded it to Tracker to find its position. After seeing the physics behind this object, I used these findings to update the GlowScript Base 2 code to compare the models of the predicted and observed. From the tracker data, I was able to see the position versus time graph, velocity versus time graph, and acceleration versus time graph to come to a general consensus on how drag affects this system. As we can see in the position versus time graph, there is a slight slope downwards. Velocity has a exponential general curve, and the acceleration is more of a consistent trend. With this information derived from Tracker, I updated the GlowScript code at the highlighted lines in order to create a predicted accurate model. For line 56 specifically, the value of B was found through trial and error to see which value accurately represented drag in the system, and then we updated stuff such as the weight, the force of drag, and the F net, including the weight plus the force of drag, and updated the balls code that got the velocity and position. After updating the code, the graphs shown on the screen are with the predicted models including drag from the code, and we can see a general downward prediction of position versus time, and with velocity versus time, we have more of a downward exponential slope. For comparing the models, the gray line represents my observed data found in Tracker, the blue line was the direct data from the predicted model shown earlier that includes drag, and then lastly the orange model was GlowScript's prediction of the system neglecting drag, which I derived from removing drag from the base code. As we can see, drag creates a more consistent velocity throughout the system as it falls, which reduces the effects of acceleration and change in momentum, versus without drag we have more of a intense sloped downward motion. For the post-exam reflection questions, the first one asks if any of the models predict terminal velocity. First, terminal velocity is when the net force is equal to 0, therefore there would be no acceleration and velocity would be constant. I found that the predicted velocity versus time graph represents this terminal velocity in the latter half of the system. We can see that there is a steady velocity that is consistent or constant, therefore it would have no acceleration and the terminal velocity would be achieved. And then for the what if question, where you imagine the object was initially thrown down versus a 0 initial velocity, the system would still achieve a terminal velocity in a shorter amount of time that would equal around the initial velocity versus a system where the initial velocity was at 0. And I found this model by just changing some of the features in the GlowScript code to see what the predicted model would reflect. In conclusion, I found that the drag affected our paper plate compared to a more solid object such as a rock. Looking at the observed versus predicted models, each supported each other in how it drags the system versus a predicted model neglecting the air resistance. Looking at the momentum principle, we see our line after the initial drop evens out to be a more constant terminal velocity, therefore the change in momentum would be 0, and therefore there would be 0 acceleration that would be applied, and that eliminates Newton's second law. With this lab, some potential errors that could have arrived that affect the data would be recording and the camera warping, the plate being damaged, and possibly working on an incline. Thank you for watching my video.